is Artem Reshetnikov. Artem is a deep learning researcher at the Barcelona Supercomputing Center. He graduated from the Autonomous University of Barcelona in 2019 with a master's degree in engineering. His current area of interest is the intersection of natural language processing and deep learning, and applying semantic metadata for improving object detection and caption generation. Artem is passionate about art and machine learning, precisely the topic of what he will present today. He will present a solution for the enrichment of metadata of paintings using deep learning and natural language processing. Artem, please, the session is yours now.
Hi to all. Thanks, Nuno, for this very nice introduction for my presentation. I didn't expect it, but it sounds really great. Actually, today we will talk about such an interesting topic in machine learning, which calls fairness. And I would like to explain you how the fairness can influence on the machine learning and artificial intelligence solutions, which we try to implement in libraries and in GLAM institutions in general. This is the main idea of my presentation, and let's start. Let's explain and let's see what we have right now. First of all, I would like to explain what the fairness is and what topic we would like to discuss today during my presentation. So basically during like last 20 or maybe 10 years, the digitalization is main part of work in any global institution, because of several aspects. We know that we would like to utilize our art objects to save it for the future. We would like to utilize it to investigate, to explore it for the future, to get some insights, or to use for another reasons. But apart from that, this process, the process of digitalization, allows us to work and to implement some artificial intelligence and machine learning solutions in GLAM institutions, and this can change the way of interaction between the users and GLAM institutions. Here on my presentation, you can see few examples how AI, machine learning, and digital art objects can help the GLAM institutions to contact, to talk with users in a new way. It can be like automatic metadata annotation, because big libraries and big GLAM institutions, they have like a lot of different art objects, and they would like to annotate it somehow, to structure it somehow. We are talking about the new forms of interaction with users through web pages and applications. It can be VR, it can be AR, it can be mobile applications, whatever. We are talking about the interaction with minorities, such as visually impaired citizens. They would like to visit the museums and libraries as well, and the modern AI solutions and ML solutions can help. And obviously, we can talk about the improving search engines on web pages, in applications, search engines in data collections and art collections. So basically, there are much more cases where AI and ML can help. But at the same time, we have to understand that any technology has own risks and over benefits. Right now, we are talking about the benefits. We are super excited about the AI. We are trying to implement it everywhere just to make our life easier. But at the same time, we have to understand that any technology is a risk as well. and we have to take into account these risks. One of these risks is a risk which I call fairness. In machine learning community, there are two interchangeable concepts which calls fairness and bias. Fairness can be explained by biasing, so that's why I would like to start from bias. Bias is a concept when the machine learning solution, machine learning model, is biased towards some results. The simplest example, which normally book authors provided, is when you train the machine learning model, and machine learning model decide to give the credit to the bank user or not. Some researchers showed that this type of the model, they were biased to some ethnic groups, and they decrease the possibility of giving the credit to some ethnic groups. Biasing can be found in any type of the division of the social groups. It can be biased to the gender, sexual orientation, ethnic groups, whatever. Fairness is a concept when we are talking about the machine learning and saying that the model is fair enough to any kind of the group which will use this machine learning model in the future. What does it mean? It means that, for example, if the man and the woman will use this machine learning model, they will receive the same results without any discrimination. It was just an example. And like people can say, okay, this is really interesting, but what connection between the global institutions, between the libraries and fairness? I would say that it's really important because we are talking about the user experience. And in a future slide, I would show you a few examples where the fairness can play a significant role. First of all, we have to understand why the data which we use and machine learning models which we use should be fair. For example, there was research of Princeton University about producers which machine learning and artificial intelligence can get copies from the human perspective. Taking into account that all data which we develop, which we produce for machine learning is produced by the people, without our intention, sometimes we put our stereotypes in this data, and by the model it can be learned. How does this topic relate to the global institutions? For now, I mean, obviously I could find many more cases, but today I would like to focus on two main cases. And we'll explain how the fairness and how the bias model can influence on the output results of any machine learning model. The first one is the case of our project, St. George on a Bike project. The main idea of the project was to build a system which would be able to annotate the images from the libraries, from the museums, from any global institutions in an automatic way. So basically what we did, we collected the data, we trained the model, machine learning model, and this model was able to detect the objects, different type of the objects like person, sword, helmet, and much more. This model was able to detect the position of the body, just to be able to say that the person is sitting, person is standing, person is running, begging, riding a horse, whatever. And the model also included the captions. So basically, the model tried to generate the human-readable captions for this. We built this data set, we trained the model, we were so proud of it because it was the biggest data set in the LAM community, and I guess it was the first one for object detection or something like that. But lately we decided, okay, let's investigate the behavior of the model. And we figure out that the model is biased. The model is biased to some ID group. Here you have two examples. Two paintings where we try to detect the objects. The green bounding box, the green border, the green rectangle is a class person. So what we figure out that if the person is white, the model detects it as a person. But if the person is another ethnic group, like Black, Asian, or not white at all, the model sometimes can make the wrong decision. Sometimes it say that it's a monkey, sometimes it say that it's another class, and our first impression was, okay, it's just a mistake, I mean, the model is not perfect as any machine learning model, it's just a mistake, but we figure out that there is a pattern. There is a pattern, and we figure out that yes, the model is biased to some ethnic groups. This is the first case, and I will explain later where and how the model got these stereotypes. But I would like to show you another case. This is the case when we started to work with classification systems. The idea was to use the icon class classification system just to be able to understand the structure of the data and the structure of the art objects in general. And we figure out that this classification system is it contains a lot of stereotypes. And here you have some examples. For example, like if you're talking about the laugh in general, we have really nice group of the art objects where we can see like laugh meetings, couple of flowers, and all this stuff. But if we are talking about homosexual laugh, the grouping is potentially offensive because in a homosexual laugh group we can see the topic of the objects which are not related to love at all. But at the same time, also we thought, okay, maybe this is like the real representation of the art. Maybe we don't have the examples of homosexual love in art, and we figure out that no, it's not true. There are examples, there are good examples, and they are not related to such offensive group. But how the models, how the artificial intelligence can get these stereotypes? I mean, basically, it's just data structure. It's just like the way how we classify the data. It's not the data at all. I mean, it's just the way how we use the data, how we classify the data, how we structure the data. And we try to understand, and we figure out that there is really interesting concepts in machine learning which calls data leakage. What does it mean? It means that a part of the main data set, machine learning model try to get the information out of the data set. These concepts can be explained by the structure of the data set. These concepts can be explained by unbalancing of the data set and such type of the additional problems which normally the machine learning pipeline has. So how these data leakage related to our two cases? Regarding the Sun Joke and the Bike project, we figure out that we scrape the data in automatic way, and then we annotate it in a manual way. But at the same time, we have to understand that we used the web pages of different museums and libraries. And these web pages, they follow their internal structure of the data collections. So it means that if some person, like early in 80s, for example, decided that this object should be related to this category, and from this point, the museum and the library follow this data structure, this idea will leak to our data set because we scrape the data in an automatic way. So for example, like if the painting about slavery, it's normally not related to the category of person, it's related to the category of slavery. But when we try to collect the data, we searched the paintings on the category person. So that's why we follow this data structure, and this was leaked to our data set. The same situation with icon class. For example, a lot of museums and a lot of libraries, they try to structure their internal data collection somehow. And normally icon class is the best one. I mean, I'm not against it. But if you follow this data structure, and if you will train the model and put this model in production, for example, it can be like search model. For example, if the person from LGBT community will search the art objects according to keyword love, he or she will not be able to find the paintings of homosexual love, which is not represented his or her identity. No one was saying that I have just 5 minutes. Cool. So here we have the main pipeline of the any ML project. We have really good idea. We decided, okay, let's use AI. We started data collection. We scraped the data, use the tags of publicity available vocabulary or classification system. We prepared the data, we trained the model, we put the model into production, and in that moment, the data was already spoiled because we haven't made a review of the data structure. So that's why the user experience without awareness of the fairness results will be biased. What we can do? Yeah, this is really a famous phrase from the Google. So algorithms don't remember the incidents of unfair bias, but customers do. What we can do? I mean, first of all, we have to be transparent. We have to say that, okay, fairness is important, and we have taken into account the fairness when we build our models or start any ML project. The easiest way, test, tune, and test again. You have to test the model from the different perspective, from the different social groups, just to be able to understand if the results are fair enough. Seek the different point of view. I mean, we're trying to build the team as diverse as possible, just to be able to evaluate our projects, our ML projects from different perspectives. And ask questions. So ask questions if your model is fair enough, if it produces real data, if it's not biased towards some social groups, and this can help you avoid such stupid mistakes which we had before in our project. Thanks to all. I'm ready to answer your questions.
Thank you very much, Artem. You're ahead of time, so we certainly have time for questions. We have a comment. So someone said that it's really interesting in this talk. I was talking with an archivist friend yesterday about machine learning and archival description, and any individual archives often doesn't have a ton of training data, not at the scale that machine learning really benefits from. And every institution in the middle of trying to improve our description for both completeness, scope, and improving language. So removing biased language, better describing women, and not just appendages of their husbands, etc. And also trying to describe our backlogs. So it's just a comment. I don't have the name of the person. But yeah, do we have any further questions from the audience? So maybe I'll try to ask a question. If I mean, in your machine learning models, do you have a way to try to, let's say, avoid this kind of bias or unfairness by injecting or checking the results for different probabilities for the classes that come for an identification of an object?
It's a really difficult question because in machine learning community there is really famous phrase garbage in, garbage out. So machine learning model is just a set of numbers. It's just a formula which produces the output. And it's really difficult to detect unfair or biasing towards some classes on the output of the model, because the model is already trained, it's already started. So basically what I would suggest is to start looking on fairness concepts at the beginning of the project. So when you're connecting the data, when you're preparing the data. So yes, as it was in the comments, so trying to avoid offensive language, trying to understand what type of the objects can be biased or can get unfair results, what type of the users can be offended or can be biased. And at that point, at the point of data preparation, we have to think about it. If you will think about it on this step, on this stage of the project, the results will be fair at the end.
Thank you, Artem. Do you know if there are any efforts to move closely, more closely related with the examining icon class concepts for bias?
First of all, I haven't heard about it because it's really complex problem. So it can be done by one person or by even like one research team. Icon class is really important classification system for the community. And if we will start this the process of examination of icon class, we have to do it in the community together. So basically, it shouldn't be done by one person or by one institution or by one research team. The community, the ground community, have to decide. Okay, this is time when we have to review the icon class according to our needs and according to needs of current time. Then we have to make the diverse group where like a lot of different social groups will be represented, and from this point we start. We have to start this process.
Thanks, Artem. I think we have no further questions. Wait a minute. Oh, yes, we have one more, and we still have some time. So, did you put this model with errors into production, or did you run tests before putting it in production, and did those errors not turn up in the tests?
Actually, the model is not published yet, first of all, so we didn't put this into production. I mean, it's not published for for the Black community. We published the data set. We tried to fix these errors before because we found this biasing towards some ethnic groups before the publishing the data set. We tried to fix it, and we tried to get another type of the errors in the model. So I hope the final version of the model will be fair enough for everyone.
By the way, do you know when it's expected to be published?
No, you have to talk with Maria Cristina, not with me about it.
Very well, fair enough. Okay, thank you, Artem. This was a very interesting talk. And